This lesson introduces hyperbolas and graphing of hyperbolas. A hyperbola is a conic section. By slicing the cone with a vertical plane, we get the hyperbola. What we're seeing here is half a cone. The full right circular cone looks like this. By slicing the full right circular cone with a vertical plane, we get two curves that go together to form the hyperbola. Note that this is only the representation of a cone. The true surface of the cone extends infinitely. Here is the sketch of a hyperbola. The hyperbola begins with two foci, F1 and F2. The hyperbola is the set of all points in the plane such that the absolute value of the difference of the distance of a point to F1 and the distance of that point to F2 is a fixed number d. So what that means is if there is a point on the hyperbola and the distance from that point to F1 is d sub 1, the distance from that point to F2 is d sub 2, then the absolute value of d sub 1 minus d sub 2 is equal to our fixed number d. A hyperbola has a transverse axis that passes through both foci. The center is on the transverse axis, equidistant from F1 and F2. The hyperbola crosses the transverse axis at vertex 1 and at vertex 2. The hyperbola has a conjugate axis that is perpendicular to the transverse axis and passes through the center. The hyperbola approaches two asymptotes. A horizontal hyperbola has a horizontal transverse axis. A horizontal hyperbola in the xy coordinate system has the equation x minus h squared over a squared minus y minus k squared over b squared equals 1. The center is hk. The equation starts with x minus h squared over a squared instead of the equation for the vertical asymptote that begins with y minus k squared over b squared. For all hyperbolas, x minus h squared will be over a squared and y minus k squared will be over b squared. A is the distance, the horizontal distance from the center to each vertex. C is the distance from the center to each focus. B is the vertical distance from the vertex to the corners of a box that we will use in graphing the hyperbola. The asymptotes will pass through the center and through the corners of this box. Note that b squared equals c squared minus a squared for all hyperbolas. For vertical hyperbolas, the transverse axis is vertical. Note that the equation begins with y minus k squared over b squared, and the transverse axis is parallel to the y-axis. Here b is the vertical distance from the center to each vertex. A is the horizontal distance from each vertex to the corners of our box. In general, for both horizontal and vertical asymptotes, the number under x is the square of the horizontal distance, while the number under y is the square of the vertical distance used in drawing the box. If you remember this rule, you will avoid problems that might arise when you come across a different version of the equations we are using here. Let's sketch the graph of the hyperbola. X squared over 4 minus y squared over 9 equals 1. Since we begin with x squared here, we'll use the equation x minus h squared over a squared minus y minus k squared over b squared equals 1. And let's start by finding the center. To find our center of this hyperbola, x minus h will be equal to x, indicating that h will need to be equal to 0. Y minus k will equal y, indicating that k equals 0, so our center will be 0, 0. I'll go ahead and plot the center. Next, let's see if we can find the vertices. Okay, well in this case we have a horizontal transverse axis which passing through the center tells us it will actually be the x-axis here. Along the transverse axis, I will need to go a units to the right and a units to the left. And note here that a squared will equal 4, so a will be equal to 2. That results in vertices -2, 0, and 2, 0. Let's go ahead and sketch the box. To sketch our box, we need to figure out what b is. And if b squared is equal to 9, b will be equal to 3. So from our vertices, we go up 3 units, down 3 units. And I'll just use a little dashed line to sketch the box. Well, let's go ahead and draw these asymptotes that go through the center and through the corners of the box. We'll be all ready to sketch the hyperbola. But before we do that, why don't we determine the equations for the asymptotes? This first asymptote passes through the point 2, 3 and through the center 0, 0. Using y equals mx plus b, I can see that the slope here will be 3/2, and b will be equal to 0 here. So my equation for the first asymptote will be y equals 3/2 x. The second asymptote passes through the point -2, 3, resulting in the equation y equals -3/2 x. And finally, let's use the vertices and the asymptotes to sketch the hyperbola. Notice we go through the vertices and we approach the asymptotes as we're sketching the graph here. And there we have it. Try on your own. Sketch the graph of the hyperbola x squared over 9 minus y squared over 4 equals 1.